what we're going to be looking at in chapter 9, I think you're really going to enjoy. I really enjoy these type of problems. We're going to be looking at trig identities and equations and just really creating a formula chart, if you like, of different ways that we can use these tools to manipulate the situation that we encounter. What's really neat about these identities and equations is they all serve a purpose. If you're working on something, you might pull tool A to simplify stuff up, and then pull tool B to modify it and switch it around, etc., etc. And so I think the best thing that we can do is kind of get our feet wet, explain some things, work through things, and I'll kind of prove some along the way. So I hope you enjoy this section as much as I do. What we're going to start with is Pythagorean identities. And with these Pythagorean identities, this is our main one here. We've already seen this earlier in another chapter in use of different items. But what we're going to do is really work with the nuts and bolts of this. So what I want to do is I'm going to take this Pythagorean identity here and show you how these other two evolved just by using this fact. And so what I'm going to do is I'm going to start with this 1 plus cotangent squared theta, and I'm going to show you how I can get cosecant squared theta. So the first thing that I'm going to do is I'm going to remember a couple of things along the way. Let's remember what cotangent theta is equal to. It's equal to 1 over tangent theta. Well, if we remember what tangent theta is equal to, it's equal to sine over cosine. So I can also know that 1 over tangent would just be the reciprocal of this. So it would be cosine theta over sine theta. So I'm going to use this knowledge of cotangent equal to cosine over sine and make a substitution here. So this would be equal to 1 plus, instead of cotangent squared, I'm going to say cosine squared over sine squared. Now 1 is a very simplified object here. I'm going to kind of unsimplify it and turn it into something else, but still equivalent to 1. And I want to turn it into sine squared theta over sine squared theta, because something over itself is just 1. Bring down this next part. And you can see now I have two fractions that have the same denominator, so I could just add the numerators. Sine squared theta plus cosine squared theta all over sine squared theta. And by our first identity here, we know sine squared plus cosine squared is equal to 1. So this would be 1 over sine squared theta. And we know 1 over sine squared is equal to cosecant squared. So you can see that 1 plus cotangent squared theta is equal to cosecant squared theta. This would be a nice proof that I might ask you to do. What is 1 plus cotangent squared equal to? Or prove the following identity. But for other problems, we'll use this as a fact in order to maybe manipulate something else. But I just want to kind of show you how that worked out. So now we have two identities in our pocket here. Now I want to work with this third one. So let's go down here, and I want to work with 1 plus tangent squared theta. I want to manipulate it and show you how this is equal to secant squared theta. And so what this gives me is 1 plus, again, remember tangent from over here is equal to sine over cosine. So I could say, you know what? That's equal to sine theta over cosine theta squared. String the equal signs here. Instead of writing 1, I'm going to do something like I did here. I'm going to put something over itself, and that something, I'm going to make it cosine so that I could put maybe these two together. So I could say cosine theta over cosine theta squared. That's just a 1. 1 squared is 1. And so now you can see again, I've got two fractions of the same denominator. So this would be cosine squared theta plus sine squared theta all over cosine squared theta, cosine theta is equal to, well, cosine squared plus sine squared, back to our basic, equals 1. So this gives me 1 over cosine squared theta, which is equivalent to secant squared theta. So you can see that I started with 1 plus tangent squared theta. I followed my string of equal sign here, and I've landed at secant squared theta, which is our third fact that we get from our Pythagorean identities. And so it's important to know, what can you work with, these three things. You can manipulate them. I could subtract sine squared over and tell you that cosine squared is equal to 1 minus sine squared. I could move things back and forth on the equal sign, modifying my symbols as I need to. These two proofs are really handy, and we're going to see some other identities and formulas kind of fall out accordingly. Now, that being said, with these first two, you should be able to complete homework number 2 by working through these. Now, on to even and odd identities. In previous lectures, we've made comments about even and odd. We've talked about how tangent is odd, our sine function is an odd function, our cosine is an even function, and then how these kind of play out accordingly. Now, what's beneficial about this is that if I have knowing if it's an odd or an even function, the placement of this negative helps me see if I were working with cosine of negative theta, that's equal to cosine theta, so I could rewrite that in hopes that I can manipulate it like we did above more efficiently. And you'll see in just a minute that I'm going to use this factoid of sine of negative theta equal to negative sine theta in order to manipulate some other algebraic equation here with my trig functions in order to get to the answer that I'm hoping to get. And so I want to kind of just make a comment here and talk about the evenness and oddness of them, because that's going to help with our substitutions as well. So we've got our Pythagorean identities, we've got our even and odd identities. We come up here to part 3 and we have our reciprocal identities. Now with the reciprocal identities, we already know some of these, but I thought it'd be really nice to have them in our notes. So we've got sine is equal to 1 over cosecant, cosine is equal to 1 over secant, tangent is 1 over cotangent, cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tangent. We've worked with those, we've talked about them. I just wrote a couple of them down. I just want to kind of clearly identify them, give you a place in your notes that you have those written down. Then we've got quotient identities. And again, we've already done one of these. We've looked at tangent being sine over cosine. And even in example 1, we looked at cotangent being cosine over sine. So we've got Pythagorean identities, our even and odd, our reciprocal, and our quotient identities. And then there's this really nice page. And this comes out of your textbook. So it's something if you like, if you want to print off a version from it, you could do it from your notes or from your textbooks. And it puts it all in one place. Pythagorean, even and odd, your reciprocal, and then your quotient. And so we're going to use this page here as we move forward. I know it's in very small print, but I want to kind of show you to give you a visual of what you're looking at. And this would just be summing up your identity. So if you were printing off the notes and writing on them or referencing your textbook, which is embedded in Canvas, you would have that super great page to definitely reference as you're working through these lecture notes and as you're working through your homework problems. So all that being said, what I want to do is I want to move over and go to part 6. And let's talk about verifying some of these identities. And we're also going to work with some algebra here in a minute. So here's what we want to do. If the problem said to verify the following identity, and such as this example here, it says verify this identity, then what I want to do is I want to start with the left or right side. So for instance, I want to start with maybe this left side, and I want to work and manipulate until I get to equal to the right or left side, whichever one you started on. So I'm going to work about 3 examples here on this page, and I want to show you how I'm going to start with this left side, and my end goal is to finish with just the right side. And so I put left/right or right/left. You could start on either side. For these 3 examples, I'm going to start on the left side. It's a little more complicated and show you how it simplifies up. So the good news is you know what your answer is going to be. But this is epitome of a math problem. It's one of those where you have to show your work in order to get full credit for it, because that is what I'm looking for. Can you verify the steps along the way? And so I'm going to start here with tangent theta equal to cosine theta. Again, my end game is to figure out sine theta. So I'm going to first remember a couple of things. I know that tangent of theta is equal to sine theta over cosine theta. If it's equal to tangent sine theta over cosine theta, that is going to be really nice because I noticed my other part of my problem also has cosine in it. So instead of tangent, I'm going to write sine of theta over cosine of theta. Move this cosine theta over from the original problem. I can make some cancellations from here. My cosines would cancel, and this ends at sine theta. So a couple of notes over here, but I've shown in one step how I can verify that this is equal to sine theta. Now, this is not a specific identity or rule like we did with some of the previous ones, but it is just showing you how did we arrive at that conclusion using some other identities along the way. Now, the next one looks a little bit more complicated, but I'm going to pull in some of that even and oddness that we discussed earlier. So we want to verify that this left side is equal to cosine squared. So again, I'm going to start with the left, and I'm going to move to the right because the left looks a little bit more complicated. I'm hoping that I can make some substitution and identities and work it from there. Something to remember is that sine of negative theta is equal to negative sine theta by that second page where we were looking at the even and oddness of functions. So these two are the equivalent. I'm going to make this substitution here with this back piece. So I have 1 plus sine x times 1 minus sine x. Instead of a negative x, I can put it out front because of the function. Now I'm going to multiply this together, and this gives me 1 minus sine squared x, doing 1 times 1, distributing out. It's also the difference of two squares. And then I'm going to pull in, so here's kind of my side notes, I'm going to pull in the fact of the Pythagorean identity is equal to 1. And I know that if I were to move this over here, that 1 minus sine x squared would be equal to cosine squared x. And so you can see I started on the left, I arrived on the right, I used the fact of the even and oddness of the functions, I did some algebra, and then I used my Pythagorean identity. Now on this third one, again, I'm going to start with the left and move to the right. It looks a little bit more complicated, and there's actually two approaches to this, and so I'm just going to show you one of them. The first thing I want to do is I want to start with this left side here, and I want to break this apart. This may have been two fractions that were put together by subtraction because of common denominator, so I'm going to separate them out again. So this gives me secant squared over secant squared minus 1 over secant squared. I'm going to simplify this up. This is a 1. 1 over secant squared, well, secant is equal to 1 over cosine, so I'm saying minus cosine squared theta. And our Pythagorean identity shows us that if I were to subtract cosine squared over, 1 minus cosine squared would be equal to sine squared. So I started with the left, I've landed at the right, and again, this is just one of two approaches that you might take for this problem. With the notes that you have so far, you should be able to complete 1, 2, 3, 5, 7, and 10 of your online homework. So I just want to kind of make that reference here. Now for this last page, I want to work 3 more examples, and I want to go to part 7. I want to use algebra to simplify up some of these trig functions. So I've got 3 examples that we're going to work through together. First of all, it says, write the following trigonometric expression as an algebraic expression. And so I want to write this without the trig parts. So I'm going to make a substitution. I'm going to let x, my favorite letter, equal cosine of theta. And I'm going to rewrite this problem. So I'm going to have 2, instead of cosine squared, I'm going to call it x squared, plus, instead of cosine theta, I'm going to call it x minus 1. So you can see that the red of the cosine theta was just replaced with x. The rest of the column followed suit. Now that it looks like an algebraic expression, I could factor it, and this would factor into 2x plus 1 and x minus 1. And the next one, I want to look at 2 tangent theta times secant theta.